Okay, let me give the solution for this. So when you talk about the considering the statements about the multi-objective reconfiguration, so power losses can be minimized along the worst voltage drop. Second is talking about the SAFI and DAFI can appear as a objective function. Average service ability index can be included. Okay, and the multi-objective reconfiguration encode ignores the interrupted customers. Okay, so when you talk about these statements, first is talking about this power loss can be minimized along the worst voltage drop. So, so in this multi-objective reconfiguration, the power loss can be minimized together with the worst voltage drop. Okay, this shows that the problem does not focus on the only one technical parameter, which is the power loss, and also tries to improve more than one performance at a time. Okay, so that's why the past statement is correct. Let's talk about second statement. Sapphire and Davy can appear in the objective function. That's also correct. If it is a multi-objective reconfiguration problem, so you can add the reliability indices also into the objective function. Okay. So third is the average service ability index can be included. So this is also because when you talk about the which lines to be activated at a particular time, so their ability index is also being carried out into the objective formulation. Okay, so and also because the service quality and continuity can be optimized along with the electrical performance measures. When you talk about the multi-objective reconfiguration, ignore the interrupted customers. So that is false because they considered it. Okay, because it have to meet the all the loads which were there in the system, considering the losses as well. So the from source side, when you're optimizing the things, so you have to consider that which system is actually interrupted in between. Okay, so that's why this all first, second, third statement is correct, with the fourth is false. Okay, so option B is correct. Let's move further. In this problem, when you see they are saying the following statement about the multi-objective optimization approaches. So there are four options are given that weighted sum approach is used, fuzzy multi-objective approach is used, and also it is talking about the Pareto based approach is used, or only one of these approaches applicable in the reconfiguration. Okay, so when you talk about the first statement, the weighted sum average approach is used. That's true because it have to be if you are using the x as net to be 0, or considering the loss in between also you can add into that. Okay, second statement, when you see the fuzzy multi-objective approach can be used, so that is true because it's a methodology, so you can use the several objective considering the soft limits inside of the strict hard limits. Okay, Pareto based approach, so this is also correct when you can use the suitable objective conflicting and set the trade-off solutions which is required. Okay, fourth option, it is considering the only one of these approaches applicable to reconfiguration. So that is false because you can use the notable the clearly mentioning the all three approaches as a valid methods for the multi-objective optimization. Okay, so this is not true. Okay, so in this option, the first, second, third is correct. So option B is actually correct. Okay. Let's move further. So when you talk about the considering the following statements about the Pareto-based multi-objective optimization, so here the first statement is given that it is useful when the objectives are conflicting. Better values for all the optimizations may not exist simultaneously. Not dominated solutions are preferred. The set of the such trade-off is a called as a Pareto front. Okay, Pareto front. Okay, so the statement first is talk about the Pareto-based multi-objective approach is basically useful when the objectives are conflicting in nature. So in this distribution network configuration, the objectives such as cost, reliability, power quality may not improve together in the same direction. So because of this conflict, the trade-off based approach becomes necessary. Okay. So when you talk about the better values for the optimizations may not exist simultaneously, that is also correct. But because you have to take in the situation that you should correct one and you cannot neglect one other part, but at a optimal places you can figure it out. Okay, all three parts. Okay, third, when you see the non-dominated solutions are preferred, so you can see the Pareto based optimization. So non-dominant solutions are preferred because they provide the best possible trade-off among the competing optimized objectives. So a non-dominant solution means that no other solution is better in the all objective at the same time. Okay, fourth, when you see that the set of such state of solutions is called the Pareto front, that is also correct when you have a collection of the best trade-off solutions. Okay, Instead of producing one answer, you have the multiple optimization, which is giving the good solution. So this is called as a planner, when the planner of the operator can choose the depending upon the their practical priority. Okay. And also in this problem, when you see the classification of the reconfigurations, there are multiple reconfiguration methods are there, either heuristic method, meta heuristic methods, mathematical optimization method, or hybrid models. Okay. So when you see the statement, so you can use the either of them. Okay. So the all options is actually correct, option C. Okay. So these are the basic classification of the reconfiguration method. So when you have the reconfiguration method, so you can use the either heuristic method, or you can use the meta heuristic method, or you can use some mathematical optimization, or you can use the hybrid of the few of them. Okay. So this option is actually correct. So when you see the statement, basic statement about the reconfiguration algorithm, so which statement? When you see first statement, the all normally open switches are first closed to from a mesh network. Loads are converted into the nodal current injection before running power flow. The switch carrying the lowest current is open first based upon optimization flow pattern. Constant checking is necessary in the algorithm. Okay. So when you talk about the first statement, it is correct. Okay. Because when you this is so important because it creates the possible alternative path that can later be examined for selecting a better network configuration. Okay. When you talk about second, the load was converted into the nodal current injection before running power flow. So this is also correct. This help to determine the how current and power can be distributed through the system under the new switching condition. Okay. Third statement, when you talk about the switching carrying the lowest current in the open first based upon optimal flow pattern. So that is also correct because this is done as a part of process for restoring a radial configuration while aiming the improving the operating performance. Okay. When you talk about the fourth, the constant taking necessary in the algorithm, that is false because when you talk about the means ki ignoring the necessary constant which is there. So this is false. When you have to consider the constant either in the power side, either in the power loss side, either in the power quality side. So any violation which is existing, the algorithm repeat the switching process until the acceptable configuration is obtained. Okay. So this is option first, second, third is correct. The fourth is false. Okay. First, second, third. Option B is correct. Try to solve this. So when you see this statement about the algorithm illustration, so we have the four statements. Either first talking about the genetic algorithm is selected for the reducing the distribution system power losses. So this is actually shows the genetic algorithm used to optimization tool for obtaining a better switching configurations. And the first statement is actually correct. Okay. When you talk about the second statement, this is means the BPSO is applied to determine the switching arrangement that allows more photovoltaic generation to be accommodated in the feeder. Okay. So the second statement correct. Third statement, when you talk about it, is talking about the hosting capacity of the PV. Okay. So this affect the network performance. That is correct because when you directly stating that key nodes why reconfiguration can be useful, so you have to consider maximum amount of PV that can be accommodated inside of the, that is called basically the PV hosting capacity. And when you talk about BPSO illustration, so tie switches combination which is optimized, that is also correct. With this clearly indicates that tie switch combination which you are using, it is being optimized to obtain the best reconfigured feeder structure. Okay. So the option 4 is also correct. So when you see talk about the statement, so all first, second, third, fourth statement is correct. So option C is actually correct. Okay. In this problem, when you're talking about the distributed generation, okay, the first statement is talking about the purpose of DG is to provide the source of active electric power. Okay, but that is true. But in some sense, also the DG can support the reactive power support, give the reactive power support as well. Okay, and these can be connected directly in the distribution system, though that is when you talk about this is also correct. You can connect the DGs at the distribution site at the load point with it, where it is required. Okay. Third statement talk about DGs can be also connected to customer side of the meter. That is also correct. You can connect the DGs may be installed locally at the consumer premise and usually close to wherever the power is needed. Okay. Talking about the fourth statement here, the embedded DC always refers to the bulk transmission generation. That is actually false. Okay. So for the bulk power transmission, the DGs do not refer to the bulk transmission generation. Okay. So this refers to local generation whose output is mainly used nearby or locally. Okay. So the option 1 to 3 is correct, but D is false. uh, DC energy sources types. Okay, when you talk about the all the statement, when you see the either is a gas turbine or it's a wind or the biomass or the energy sources with of the DC units called DER, that is also correct. So option all the statements were actually correct. Okay. This is related to the classification of the DGs. Either is a macro DG, small DG, medium, or the large DG. So based upon the power capacity, you can categorize the DGs. Okay. So the all the statement when you see the 1 watt to 5 kilowatt, so they are called as a micro DGs. Okay. 5 kilowatt to 5 megawatt, they are called as a small DG. Okay. 5 megawatt to 50 megawatt, they are called as a medium DC. Okay. 50 megawatt to 300 megawatt, they are called as a large DGs. Okay. So these all classification is actually correct. The option C is actually correct. So 1 to 5 micro DC, 5 kilowatt to 5 megawatt is small DC, 5 megawatt to 50 megawatt the medium DC, 50 megawatt to 300 megawatt is a large DC. Okay. And when you talk about this statement there, on operation capability, that whether they can operate standalone or they can operate with the grid connector system. So first statement can be first statement correct. They can operate as in an islanded situation as well. Okay, so the first statement is correct. Second statement, when you say grid connected, is supply a large interconnected network. So this is actually correct because when you're connecting the disease which is in grid connected system, so they can be in the large interconnected network. Okay. Third statement, when you talk about the connection point of PCC, that is also correct. Standalone DC cannot operate with the storage or other generator. That is false. Okay. So that can be a possibility that you can use the storage with these standalone DGs, but when you talk about the generation, which is only the required amount. Okay. So that is also this is incorrect. Okay. First, second statement is actually correct. Talking about the other statement about the benefits of this, the benefits is that it reduces the environmental pollution. That is true. It improves overall power quality and reliability. That is true. It can increase overall plant energy efficiency. That is also true because the local injection is also there. Okay. It decreases the thermal pollution. That is false. DG is actually reduces the for dependency on the thermal power plant. Okay. So that is also it is that is why it is incorrect. Okay. When you talk about the considering the passive and the active distribution network, the passive distribution network have no DERs. So that is true. When you have no DERs, so you don't have any local generation capacity. So that is called as a passive distribution network. Integration capacity is limited, so that is false because when you have any capacity is there, so that is correct. When you have the passive network, so it's a all generation coming from the source side. Okay, you don't have any distribution side having a possibility of supplying the locally. Okay, so that is also correct. Let me erase this. Okay, this is also correct. Okay, so the active network include DER system for advanced control planning. That is true. Active network can support the landing operation. That is also true. Okay, so the all statement when you talk about the all correct, option D. When you talk about the considering the statement about the active distribution network, so these are basically the enhancing the security over the expected benefit, reduction in the investment cost, one explicit benefit. Network reconfiguration is one new control technique that is also true. Coordination of operation of the network facility is unnecessary, that is false. Okay, try to solve this. So, when you see the required changes converting from the active distributions network, so when you talk about the adaptive protection control, that is true. Wide area active control, that is also true. Advanced sensor and measurement, that is also true. Real time network simulation, that is also true. So, option C is actually correct. Let's move further, try to solve this. So when you talk about this following statement about the RE penetration, so average penetration expressed using the annual energy value. So that is correct basically. Instantaneous penetration expressed using the power value, that is also true. Maximum instantaneous penetration generally how much greater than the average penetration, that is also true. Penetration never explained in percentage, that is false. Okay, first, second, third is correct. So in this problem, they are talking about the statement about a DG operation mode. So lagging power factor DG may provide both active power and reactive power. So I talked about in the active and reactive power support previously also. When you have the suppose the capacitor bank is there, so it provides the lagging Q. Okay, and when you have the inductor there in the place, so it actually absorbs the lagging Q. Okay, so when you're talking about the lagging power factor, man provide the active and reactive power, so you have a sufficient margin to provide. Okay, so that is first statement is actually correct. So when you talk about the operational mode, so it don't not only provide the active power, it provide the reactive. So leading power factor you cannot but consume reactive power. Okay, so when we talk about, so DC is basically the provide the lagging reactive power. Okay, so when it is absorbing, it means that it consuming the lagging leading reactive power. Okay, so the second statement also when you see about it is correct. Okay, third statement, the unity power factor supply one reactive power, that is also true. When you don't have power factor one, so Q is 0 in the voltage control DG operation with the fixed voltage magnitude. So that is also when you see talk about it is correct. Okay, so in the operating mode, DG may help the voltage at a specified level rather than the simply injecting a fixed amount of power. Okay, so that is also true. Let's move further. This is the following statement regarding the DG integration capability. So they are talking about the how what are the capability can be there. Okay, so when you talk about the all category, either you have a plug and play operation, either supporting the active and reactive power support, improving the power quality also, or the fault light through also should be there. So option D is correct. When you talk about the simulation of this, the location, what are the amount factors? So location of the node is identified first, so that is also correct. So when you talk about DC active power should be determined, so that is also correct. So and the lagging reactive power power factor DC active was subtracted from the load, that is also true. And the leading reactive power, so power is added to the reactive power, so that's also true. So option D is actually correct. Okay, When you talk about the other configuration in the microgrid, statement about the microgrid, basically active distribution network, that is true. It consists of the DG system and various load address distribution voltage level. That is also true. It can operate connected to the main grid. That is also true. It can also operate in. That is also true. So all statement here is the actually correct. When you move about the microgrid advantages over the conventional network, power generated, that is also true. Microgrid generally is smaller than the conventional, that is also true. They are usually installed closer to the customer, that is because you are connected to the distribution side. They are ideal for the supplying remote location, that is also true. So option, all the statement is basically correct. So let's move to the last problem. So it is talking about the microgrid operation deployment. So it improves the efficiency, that is true. It improves voltage control, that is also true. Safety protection among the deployment concern, that is true. Okay. And the statement last, ability of communication also deployable concern, that is also true. So in this all the tutorial session today's, we have talked about few of the statements related to that which was there, and that will help you to solve the current assignment. Okay. Thank you for joining. That's all for today.